Please welcome Mr. Chicken Rocket to the stage.
Good morning, everyone. I hope everyone didn't party too hard last night and ready to hear some dense facts on optimization. Hi, I'm Peter McNeil, otherwise known as Mr. Chicken Rocket. I've been in the Roblox community now for about 7 years, and outside of Roblox, I've been making games for about 25 years. And as for the name, Mr. Chicken Rocket, well, my kids gave me that name because they wanted me to go play this thing called Bee Swarm Simulator with them about 7 years ago. And I kept the account, and so the name stuck ever since. And hi, just before we begin, just a few ground rules. Please keep your arms and legs inside of the ride at all times. There's no need to take pictures of the slides because this will all be put online afterwards. And there's a really good summary slide right at the end too. And we'll hold off until questions at the end, like with most of these talks. And there's going to be a QA room across the hall afterwards to do a bit of an extended QA if you want to catch me there. And as for me, I did some stuff. Back in the olden days, I worked on Fruit Ninja, and I've worked on many versions of Fruit Ninja since then. I worked on Fruit Ninja VR, Fruit Ninja Connect, Fruit Ninja Xbox, all of them basically. I also worked on this game called Jetpack Joyride, which I keep getting told that was a bunch of you's childhood game, and that makes me feel really old. Yeah, back in the day, that game had to ship in under 20 megabytes, so that was a real engineering feat to get that thing to even ship. And more recently, I was over in Sweden working on this thing, which I think some of you might have heard of. I was the engine director on Candy Crush for a few years. On Roblox, myself, I've worked on a whole bunch of stuff, and I've worked with a whole bunch of really excellent, amazing teams. I've shipped a couple of games myself, and I've released some open source software. But probably the most important thing, and why I'm up here talking about this today, is that I love optimizing games. I love understanding how they run and how they perform. And I've got information that I can share with all of you about that. So that leads to today's talk, using the Roblox tools that exist to improve performance, which really comes down to starting by health checking your game. And so why do we care? Why do we care about optimizing our games? Because Roblox's long-term vision is that you don't have to optimize your games, and Roblox will take care of all of this for you. But the truth is that right now, optimized games make more money. They announced at the keynote that Roblox engine optimizations have added an extra 300 million play hours over the course of since they've added them. And the truth is that more than half of your players are on mobile. Optimized games also get played longer. So people are having a session on their mobile phone, they're playing it, and if the phone starts cooking in their hand and catching on fire, they're not going to play it as long as they're going to play it if it wasn't doing that. On top of that, there's other things that count as optimization, which is load times for your games. So you've got a game, it's loading up, and if it's taking 15 seconds, 30 seconds, 45 seconds, I don't know about you, but ADHD sometimes kicks in, and I'm over on TikTok, come back to the game, and what was I doing? You know, that's not a good result that you want for your players. The good news is, and the real point of this talk, is that Roblox has great tooling to help you monitor and track down and overall check on the health of your project so that you can tell how it's going to run on these devices. And my philosophy is that it's way better to stay on top of performance and optimization as you work on your project, as opposed to making it a process that you try and do at the end. So you let your performance fall, you do an optimization pass, you come back. It's better to avoid all of that and just work on it as you go. So that's what this talk today is all about. So diving right in, I've profiled and optimized a lot of games at this point. I've worked with a lot of teams. People send me builds all of the time and say, hey, why is my game running badly? And I've seen some crazy stuff. But honestly, there's these 6 points that I'm going to bring up right now. Most games that have performance problems have problems with one of these 6 points. So that's excessive triangle count, excessive draw call count. I'm going to explain what draw calls are if you don't know, if you haven't heard that term before, I'll dive into that. High CPU usage, high memory usage, long loading times, and excessive bandwidth usage. So I'll run you through the tooling that Roblox has for all of this today and show you how to tell where your game fits on that and some current appropriate benchmarks and standards for that if you're targeting mobile phones. So to start with, triangles. Now, you're going to have to forgive me for this one because this is a very high-level, top-level talk. I have to tell you that everything in Roblox is made out of triangles. So this means your meshes, your parts, your unions, your terrain, all of it. It's all triangles. That's the primary way that Roblox gets things drawn on screen. The main problem with triangles, however, is that most people don't pay attention to it, and as a developer community, we're kind of excessive with it. We use a lot of triangles in our things. We treat triangles as high-fidelity models, and we treat it as a mark of quality, and truthfully, our scenes are excessive with it. So the number of triangles that you have in your scene, that affects your rendering performance pretty linearly. Roblox does some things to try and scale down the number of triangles that you use, based upon performance and distance and LOD. But genuinely, if you have rendering and you have a 2 million triangle scene, that takes about twice as long to rasterize as a 1 million triangle scene. So it affects things pretty linearly. So the total number of triangles you're pushing out to the scene really does affect your rendering performance. So how do you check your, just pause for a split second. When you're caring about the triangles in your scene, what I'm actually talking about is what your camera can see right now. So like triangles that are to the left of the camera or to the right of the camera, or now because we have the new occlusion culling, triangles that are behind things that are being occluded culling. Occlusion culling is amazing, right? Like, let's round of applause for the engineers for that one. But the only triangles you care about are the triangles that are actually on scene for your current thing. So when I say scene triangles, that's what I'm referring to. And how do you check your scene triangle counts? Well, that's really easy. It's the shortcuts that I'm showing on screen now, which is Control Shift F2 for Studio or Command Shift F2 for in Studio if you're on a Mac. And so when you're actually looking for your triangles and you're looking for your optimization, what I usually do is I go and find a hotspot in the scene, jump down, pull up the rendering stats menu like so, and I look around and find the hotspot. I look for when this number here, this is the most important stat in all of the rendering stats, even though it's quite an information-dense screen, is your draw scene numbers there, which is, I keep pointing at the teleprompter, sorry about that. So its number of draw calls is the first number, and the second number is the number of triangles. So this scene is drawing 77 draw calls for the scene triangle, and it's drawing 130,000 odd triangles in this view for the triangle count. There's a lot of other numbers in the rendering stats, and I'll cover a few of them in a minute, but this is the primary one that I use when I'm looking at people's rendering performance, because it tells you the overall health of the rendering scene. So how many triangles do we use? Like this one's doing 130,000. What's a good budget for your game and for your mobile phone with the state of Roblox as it is now and the types of device we're trying to target? This graph gives us a little bit of an insight into that. So this graph tells us how many triangles a bunch of different devices over time could comfortably render and stay at 60 frames per second. So all the way back on the left, we have the Nintendo 64, which could render about 2,000 triangles per frame and stay on 30 frames per second, because it was a 30 frames per second device. And all the way on the right, we have the PlayStation 5, which has a scene triangle budget of about 10 million, because that thing's a beast. And then as we go along, we have things like just on the right of where I've picked the iPhone 6 and the Galaxy 6S phone. That is at about 1 million triangles for the PlayStation 3. Does everyone remember the PlayStation 3, or is that like your dad's gaming console? Right, anyway, so we're at about the 500,000 point for the iPhone 6S and the Samsung Galaxy 6S. And the reason why I picked that phone as a good benchmark to tell people, hey, look, target this one, is because those are 2 gigabyte devices, those are very low spec, and 90% of your player base or more, like even will have something better than that to play on. So this is right down the bottom. It's not the very worst possible phone, but it covers 90% of your player base if you can make it run well on that target. So next up, let's cover draw calls. The mysterious, magical draw calls. What are draw calls? Well, draw calls kill your performance. Draw calls are the most misunderstood part about rendering performance on Roblox because people think the total number of triangles is the only thing that really affects things. It's like, my scene has 4 million triangles. And it's like, well, that's not the only thing that affects how fast it renders. Because draw calls are a command that gets sent from the engine to the rendering pipeline on the device that say, draw something. So every draw call is a combination of, this is massively oversimplifying, so any rendering engineers here, please forgive me. But this is each command, a draw call command, is a combination of a mesh and a material. So in this case, we have a teapot, which is our mesh, and then the material that goes with it. So a lot of games are like 4 to 8 times over budget on this. They've got 2,000 scene draw calls or 4,000 scene draw calls. But honestly, every draw call that you put out has a fixed performance cost in it, even if it only has 1 triangle in it. And so you can very quickly make your scene run slowly, even though you're not rendering much stuff, if you're blowing out your draw call budget. But Pete, you're saying, if we only have 500 draw calls, how are we rendering scenes with 10,000 or 100,000 parts in it? And the truth of that is that there's something else going on. Now, Roblox can let you build exactly the same thing in maybe 10 different ways. You can build it out of parts or unions or meshes or however you're going to put it together. But not all of those are created equal, and especially not all created equal when it comes to how many draw calls those things consume. So what Roblox has internally is a process called geometry instancing. So sometimes some things take more than 1 draw call to draw, or take a single draw call, or some things can get packed into the same draw call, and you end up only having to use 1 draw call to draw a whole bunch of things. So this is our example here with the teapot. If this works, it should animate when I click. Right, so we have this teapot moving around. The position's moving, the color's moving, the scale's moving, the rotation's moving. And all of these things can be changed without making it cost any more draw calls than it currently is. So all 4 of these teapots are being output by the rendering system in just 1 draw call. That's really the power of geometry instancing. And now, because we're eating pretty good as developers this year, we now have surface appearance color 3s. These also batch, so I think they need a round of applause for that one too. I actually had a note there saying hold for applause, so that was great. Yeah, so anything that batches, anything that doesn't break the batching, you should be using those freely. So when you're doing your builds and you're like, can I change the parts on these without change the color on these parts without affecting draw calls? The answer is yeah. Like all of these properties can be changed and it really aids in your ability to go and kit bash your scenes together. And if you want to hear a spooky campfire story about the olden days of game development, back in the olden days on the iPhone 4 when we were shipping Jetpack, do you know what our scene draw call budget was? It was 40. So 500's not the hugest budget in the world, but it's a lot better than what it used to be. And continuing with batching, batching is good, but it's not magic. So this is an animated slide, so I'm going to press the button on this in just a second. Different mesh IDs with different material combinations always go into a new draw call. So although you might have the same mesh, if you have a concrete one and then you have a glass one, that's going to be 2 different draw calls. It has to be the same mesh and the same mesh ID, and the same material for this magic to work. And so internally, all of the different block types like wedges, balls, cylinder parts, and all of these things, internally they're just meshes too. So they all start going into their own batches as well. But where people usually get caught off guard about batching, because things do batch together if they're the same thing, is when you start introducing transparency, funnily enough. Once transparency is introduced, the scene has to stop and start rendering of things to basically get things sorted in the right order. It has to draw from back to front. And then once you have that happening, you have to introduce more draw calls. So I'll press play on this slide just for a second. And if you watch very carefully what's going on, you'll see that as you introduce more boxes and you change properties, the number of draw calls is staying the same. 2 draw calls once you introduce a decal, but now that we start introducing transparency, this thing that was 2 draw calls when it wasn't transparent is now 16 draw calls now that it is. So that's just something to keep in mind when you're working with transparency and looking at your batching. And as with everything, I'm not saying don't use transparency, just be aware that it can add on to your total scene draw call count. When it comes to decals and texture image instances, these can also surprisingly add to your draw count very quickly. And both of those also add to your triangle count too, because anything with a decal on it or a texture instance on it has to re-render that mesh so that it fits onto the geometry. So that can catch people off guard as well. So this is a talk about health checks. How do you check on your draw calls? Well, the truth is, when you go to check on your draw calls, it's exactly the same rendering stats menu that we were looking at before. We had the draw calls, that's that number there, and then you had your scene triangles. So it's the same as before. This scene here is using 276 draw calls. And as I mentioned before, there's a bunch of other numbers in this rendering stat that also contribute to your scene draw. So scene is the most important one, but secondary one is the UI. The UI in Roblox is just geometry, meshes, and materials, the same as everything else. And if you're paying attention and you have a very UI-heavy scene, you'll see that the draw calls for your scene UI really starts to climb up. And if you're budgeting and you're caring about how many draw calls your scene is producing, you pretty much just subtract the UI ones from your total budget. So if your scene has 150 UI draw calls, well, your actual rendering, you should be targeting about 350. You probably don't have it that high, but if it does start really climbing up, you might want to have a look into it, especially for rendering on mobile. Depth, the depth number of draw calls is largely ignorable. The devices that use the depth pre-pass, which is what this draw stat is about, that's usually the PC. It's not the mobile devices at the moment. And PCs are much, much more powerful than mobile phones. Remember, we're building like a minimum draw call set here. So a PC can do 4,000 draw calls. It doesn't care about it. So having some extra draw calls being spent on the depth pre-pass isn't something you need to concern yourself about, which is why it's marked as ignorable up on the slides. And shadow draw calls is complicated. I could give a whole talk on just how to optimize your scenes regarding shadow and light rendering, because what happens is every time a light moves, every time something that's being affected by a light moves, every time where shadows are casting moves, every time a player moves inside of shadows, shadow atlases have to get re-rendered, and when shadow atlases need to get updated, that costs shadow draw calls, which is what you're looking at with these stats. And some shadows have to get rendered twice because they're part of like a big scene cascade texture. Generally, the number that I say to people to look out for here is if this is the 3 times multiple of your scene draw calls, you're in a healthy state. But if it starts going higher than that, so if your scene budget's 500, this is 1,500, 3,000, 5,000, if it's really stacking up, then perhaps you need to look at how the lighting in your scene is being done. And remember, this only applies to rendering modes and setups that actually have shadows. So this is like future, shadow map, and older compatibility shadows, things like that. So here's a bit of a batching cheat sheet for you. When it comes to deciding what batches better inside of your scenes, what uses less draw calls, and what's better to use a lot of inside of your scene, this is sort of the tier list for it. So right up the top, we have using a lot of color 3 changes on things, using a lot of surface appearance color 3 changes on things, C-frame, size, using meshes and surface appearances and materials is really the go-fast path of Roblox, and is really the most optimized way to put things together. But as it moves down, we start getting down to the transparent things right at the bottom, which need to be sorted, and then they take more draw calls up. So the trick with this is that I'm not saying don't use the stuff at the bottom of this list. I'm saying use it sparingly. Keep an eye on the fact that this does affect your scene budgets. Look at that scene budget number all of the time and figure out if this is something that you should be doing more or less of. And remember, when we're talking about budgeting numbers, it's worth adding in here that, okay, I've got a budget of 500 and 500,000 scene triangles. It's better to be under that, you know, like it's supposed to be an upper ceiling. So how did I find this out? Well, the method for finding it out is really primitive, total caveman stuff, actually. All you do is you grab a chunk of geometry out of your scene and you whisk it up into the sky and you start cloning it around with the rendering stats open, because you can see this tree is made up of 2 different mesh parts and, 2 different mesh parts, and as you clone it around, you can see that this tree is still only taking 2 draw calls. There's 9 or 16 of them there, and it's still just 2 draw calls to render this tree. That's because I can look at that and I can say, this tree batches. But if I go and look at a particle system, I know that one particle system takes 1 draw call, and looking at it on its own, isolated, I can see that when I add another particle system, well, that's 2 draw calls, 5, because there's 5 particle systems, and so on. So if I had 500 particle systems visible in the camera, that's 500 draw calls eaten up just by that alone. Remember, I'm not saying don't use particle systems, I'm just saying be aware that there's a cost associated with them. Now, on to CPU usage. So I've worked with games that have done all this stuff that I just talked about. They've optimized their rendering stats. They've brought down how complex their scenes are. They're really not rendering all that much, and they've been very conscientious about things. But they still have performance problems when they actually get onto mobile phone and are like, what's going on here? Why is my game not running well on mobile? The rendering should be fine. Well, the other half of it is CPU performance. If your CPU performance is taking longer each frame to render than 16 milliseconds, or longer, and if it's longer to render than the actual rendering, then you're going to be running at the speed of the slowest part, which in this case is the CPU usage. And so that leads into a term that's used all across the industry, which is this game CPU bound or is this game GPU bound? And how you tell that inside of Roblox is the same rendering stat that we were using before, the rendering menu. It has the numbers on it, which is how much CPU usage in milliseconds you're using per frame and how much GPU usage you're using per frame. So we can see in this one that the CPU usage is 7.3 milliseconds. If we're targeting 60 frames per second, that's well below that. The magic number for 60 frames per second is 16.66 milliseconds. So we only care about which of these 2 numbers is bigger, and it's well underneath that, and so we're all good. But CPU usage is not like GPU usage when it comes to phones. Phones, roughly, on average, especially the low-spec phones, like my iPhone 6S is clocked in at 1 gigahertz, right? That's a quarter of the speed of like your average desktop PC these days. So when you're looking at your PC CPU usage and it's like, oh, my CPU usage is 10 milliseconds per frame and it's kind of chunky, but it's okay on the PC. When you get it onto that low spec phone, it's going to be 40 milliseconds per frame and your game's going to be running at 20 frames per second. So it's really important that you keep an eye on this and understand what you're looking at and test it on device regularly. So, although Roblox can't do much to scale down your CPU usage for you, it does provide a set of really good tools for you to tell where your CPU usage is going. This is the very most basic check to get an overall CPU usage timing check, but there's better tools that you can use as well. The more in-depth way to use it is the microprofiler. There were some announcements at the keynote of improvements to the microprofiler. They're improving it all of the time. And it's really in-depth and really complex, but there's really amazing documentation on that. And I'm not going to spend any of your time today going into the in-depth details of how to do all of the microprofiler stuff, but it's important that you're aware that it exists and you use it to get a breakdown on where your CPU performance is going. So the other thing is that the microprofiler also applies to your servers when you're building games. So it's not just the client CPU usage that you can dig into with this. You can also connect to your server and get a profile back and look through it and look at what's going on top of the server, even in live games outside of Studio. So in this slide, what I'm trying to show you is a healthy looking bit of CPU usage. And you can tell it's healthy because Roblox has recently added a convenient feature where if there's lots of time left at the end of each frame, the profiler starts turning blue. So if you're seeing lots of blue in the top graph, it means I was sitting around doing nothing, and I'm going to turn the bar blue so that you know that this is a really optimized CPU frame. So blue is good news, but remember mobile is slower and you're probably not going to see blue there. And in the profiler, the other thing to look at is the vertical lines as the basic guide for reading the flame graph is designating a single frame. So you see the vertical lines breaking it up, and we can see that each frame is taking a block of time chunks, and so you can see the flame graph is not filling up the entire frame each frame, which leads us to knowing that this frame, there's plenty of idle time on the CPU. if you do something crazy like this, where you pile up a bunch of A-frames, you're going to have a graph that looks like this. This is perhaps a less healthy CPU frame. I apologize to the physics team in advance. You're really not supposed to do this. But this is a good way to illustrate what's going on when you're really maxing out the CPU on the profiler and you're having a look at it. You can see that there's tons of threads being used, which is each of the horizontal rows, and you can see that there's lots and lots and lots of stuff filling up each one of those rows. So the microprofiler, all of the documentation for what all of these tags mean is online. But generally, if something is using your CPU usage up, it's not going to be mysterious. It is going to show up in the profiler, and you are going to be able to track down what it is. And then the last thing I want to talk about with the microprofiler is excessive scripts are usually your fault. Roblox can't scale down what your scripts are doing. So if you're doing lots and lots of fun stuff inside of your scripts, like doing lots of raycasts, and you're not spreading things out over multiple frames, or you're doing big, powerful loops that touch a lot of stuff in the data model, you're going to see that show up in the microprofiler like this. Like I spawned in 10,000 coins, and it's absolutely chonking out, and it's saying, hey, there's something inside of Heartbeat here that is using up all of your script performance. Now, on to the next bit, which is memory usage. So this is an important one. If you've ever looked at your device analytics and you see a lot of crashes on phone, what crashes are most of the time in Roblox is really out-of-memory errors. So what happens is devices have a fixed amount of memory, and as your game starts using up more and more memory, you start approaching a point where the operating system on that phone will first give your game a warning and say, hey, you're using up too much memory, and the engine jumps in and tries to free up some extra memory and try and stay under the limit that it's warning you about. And then if it goes past that, or you're not quick enough, or if it's just in a bad mood, it ejects your game anyway. And that's a super bad experience for the user because the game just goes away. This can also happen if you Alt-Tab out of the game and come back and you're using too much memory, your game will get ejected and you will see a crash in your crash report. So when it comes to using memory and checking on the health of your project, most devices now, as I mentioned before, have at least 2 gigabytes of memory. There was a lot of talk during the keynote about a focus on renewed focus on targeting Android and 2 gigabyte low-end Android devices. And honestly, that's a pretty good safe bet to target these days. Like, I don't know if I'd personally care too much about 1 gigabyte devices anymore. 2 gigabytes is a really good place to target. And if you're targeting 2 gigabyte devices, the magic number when you start getting increased levels of ejection is about 66% of total memory on the device, which ends up being about 1.3 gigabytes. So that's where we end up with a metric, a benchmark for you to say, how much device memory is my client using? Well, 1.3 gigabytes is a really healthy spot for 2 gigabyte devices. And so the health check side of this, checking on your memory on device is really, really simple. You just hit F9 on a console, and right in the top of the bar, it'll say what your client memory usage is. In this case, it's using about 1.2 gigabytes. There's a caveat on that though. Right now, checking that number inside of Studio doesn't give you an accurate reflection of how much memory you're using on the client, so you have to actually go and load this up in a live game, or even preferably on device, and then go and check your memory usage there that way. The advanced version of checking your memory is also on the same menu. You just click a couple more buttons. There's the developer console where you can click down, you can say memory, and you can click around and then get a really detailed broken down graph of how your memory is used. There's good docs on how to use this thing. They're improving it all of the time. I'm not going to dig into it too much today, but it's good for you to know that this exists. You can check both your client and server memory there, and announce that the keynote was a new X-ray mode for the memory profiling that I'm not sure when that's live, but when it is, you should have a look at it there as well. When it comes to memory usage, why is it always U3 whenever anything happens? So when I've been looking at games, and the main 3 culprits for what's chewing up the most amount of memory in games is these 3 here, which is textures, part count, and honestly, audio files is the one that catches most people off guard if they haven't done any work to optimize their process. So textures, the maximum size texture we can currently upload is currently have rendering in our game is 1024 by 1024, even though you can upload larger or smaller sizes than that. This is the large size that most people use. When you have one of those set up as a surface appearance with all of the goodies attached to it, like a normal map, roughness map, and alpha, that ends up using Resident at max in the client of 2.8 megabytes. There's circumstances where the Roblox engine will automatically scale that down, but if you're doing metrics and trying to find out what a good budget is, you can multiply that out and figure out, well, if I've got 100 fully resident surface appearance textures, that's going to multiply out to about just under 300 megabytes of client memory out of that 1.3 gig budget that we were just looking at. For parts, this one catches people off guard all the time too. A part on the client, total system impact at this point is roughly about 1 kilobyte. This means that if you have 250,000 parts coming down to the client, and you can control what comes down to the client by things like streaming enabled or what's actually in the workspace. But the things that actually arrive down on the client, it's 250,000 parts is 250 megabytes. So it's like, if I've got 1 million instances in my game, well, you know what your memory usage is going to look like if you multiply that out. And with audio files have to be resident to be played. So if you have instances of audio locally on the client and they're ready to be played, they are also sitting in memory. So a little trick there or a tip there might be to don't put those on the client until they're actually ready to be played. Like if you have 12 3-minute long soundtracks that make up your game soundtrack, shuffle them around a little bit because they're just sitting in memory not doing anything. And as a bonus slide, we saw this at the keynotes, but there's now an analytics dashboard that talks about memory usage on devices and especially crashes on devices in a lot more detail. So I won't get into this too much. It was covered much better in the keynote, but that's there now. So you should definitely go to your analytics and check it out and get a more detailed breakdown of how your memory usage is going. And unfortunately, that's pretty much it for all the fun, pretty slides in the deck. We've covered rendering, we've covered the graphs, and now we're on to the boring bits like progress bars and how long things take to load. So if you've ever wondered why some games take a long time to load and load in, and some games drop in almost instantly, almost all of that comes down to the number of things that need to be replicated to the client before the client is allowed to start up. Instances especially really bog things down. So when I've done benchmarking on this, what I've found is that you get roughly 10,000 instances a second replicated down on Client Connect. So that means if you have 300,000 instances coming down to the client, that's going to be 30 seconds of load time. You should really be careful about managing this. Streaming Enabled is a great tool for bringing in the radius for newly connected players, and you should overall be thinking about how many instances are in your scene anyway. On top of this, if you're doing content-aware loading, where you have a loading bar that's looking at what's coming down in the pipeline and then not letting the player into the game until that's cleared, audio instances can be surprisingly naughty there as well because they have to be fully downloaded. Textures have to be fully downloaded before that gets cleared. And I don't have a bullet point for it, but other players' characters also have to be fully loaded, all of the stuff that's in them. So if a player connects and then another player connects and you're monitoring how much stuff still has to be loaded, that number will climb back up as other players come in and you have to handle their character appearances. So just be aware of that. We're on the home stretch now. We're on to bandwidth usage. When it comes to bandwidth usage, it usually comes down to you have too much moving stuff. So it's nice and easy to finish up with. Server-owned moving assemblies, they all cost about 1 kilobyte per replicated assembly that's moving around on the server. So if you have a bunch of balls rolling around and you have 50 of them rolling around, that's going to use about 50 kilobytes a second of bandwidth. It's a little bit less than that, and Roblox does a lot of things to try and smooth this out for you so you don't care. After you get to about 40 kilobytes a second down on the RECV stat here, it'll start round robin throttling some of things, but that's an implementation detail that's subject to change. They're improving this stuff all of the time, but as things are right now, the rough benchmark is that you should be looking at planning your game around. There should only be about 50 moving things moving around your player that you care about physics-wise at a time. And to see this stat, it's really simple. It's Command F7 or Control F7 if you're on PC, and it's that stat right there. You've probably all seen it before. It's the RECV, and it shows you how many kilobytes per second that you're using. There's lots I could add to this about saying, if this doesn't work for you, you could use custom replication or send events to move things around and things like that. But this is not that kind of talk. So maybe we can cover that in some other talk or some other paper somewhere. And now moving on to in summary. In summary, what this all comes down to is be aware of the current limitations, realistic limitations of where Roblox is right now, and get a budget. So that means covering the things that we talked about before. That's aim for about 500,000 in-scene triangles if you're targeting phone. Aim for about 500 draw calls in scene if you're targeting phone. Aim for a 1.3 client memory, gigabytes of that. I know I said 250,000 as my example for instances before, but I honestly feel like 150,000 is a really good benchmark because you're not blowing your load times out. That's 15 seconds for 150,000 instances. Keep your replication nice and low, and keep your CPU usage as low as you can, because it always surprises people how much slower things are when you actually go and get them onto phone. I know I wasn't suggesting people take photos of any slides, but if you wanted to take a photo of any of them, this would be the one to have the numbers to take with you. And tricks, because you've all taken your phone out, I have a QR code. All right, so I did an article. Some of you are probably aware of it already. I posted, I don't know if I can call it an article. It's more of a book. It has chapters. It's on the dev forum, and it really goes into detail, not just about how to go and check this stuff, but it has some more prescriptive details on things you can do to improve your situation with these, some building tips, some optimization tips. It's really quite in-depth, so if you want to check that out, that's on the article there. And that's it. We're at the end of the presentation. All right, do we have time for Q&A? Did I go over? Q&A is across in the hall? Okay, yeah, so Q&A is not now, it's going to be across in the hall. Thank you, everyone.